offshore, well, segmented breakwaters, but they're not offshore, they're actually in the bay side. And it's just another indication that we get erosion both off from the Gulf and from the bay side. That's why Grand Isle put these segmented breakwaters out there. We're going to try to get up close to the So in the back of Grand Isle, what we have are segmented breakwaters. And that's what you see all the way down along the beach. They're made of rocks, most of which come down from Arkansas, that are shipped down here, since Louisiana doesn't have this kind of material. And it's used to dissipate wave energy. So behind the breakwaters, the wave energy is less, therefore sediments can accumulate, and also there's less wave energy eroding the shoreline. And you can see where the wave energy is minimal, we get marsh grass growing. So there's both Spartina alterniflora and mangroves growing just to my right. And since we're here, this the black mangrove is extremely, as is Spartina, very well adapted to flooding, and it uses it's called the pneumatophore, and this is basically a breathing root. This is a modified root, the pneumatophore, and it has on the surface lenticels, basically loosely compacted cells that allow air to move into these pneumatophores and diffuse to the roots that need oxygen, these roots being under the water and in an anoxic environment. For years, we're going to get bigger and bigger. But when you look out here, it's most of what you see on the left and right. See, there's some big mangrove trees in there. Class, which is the rhizomatous vegetative growth of these grasses that grow in dunes and many of them in salt marshes as well. So this particular rhizome is growing from the parent population over here, and it's in a much better habitat, much better environment than this rhizome that's growing out, but it's still getting nutrients and water and carbon from the parent plants. So what you'll have is a plant potentially establishing at each one of these nodes, roots being produced at each node, and the plant vegetatively spreading out, expanding into new areas. And that's a beautiful example. The Croton punctatus is very well adapted to low moisture conditions. It has a very hairy leaf, which reduces wind velocity at the leaf surface, and as a result, a boundary layer can exist, which impedes the diffusion of water vapor from the leaf itself. So water is lost less readily in plants that have this type of hairy leaf. So this is Croton punctatus, the beach tea. So what do you find out here in this area that could be getting salt is sea rock. That's just real common. It's very salt tolerant, even its roots. Burial rocket line of sea rock, and they probably all start from the same location. That's it dies, and it dies off. This is sea rocket. So this is what I was talking about. So this is Literaria irrorata, the marsh periwinkle. And when it gets in really high densities, about above 600 per meter squared, you imagine 600 or more per meter squared, and it can get in densities like that. Into this area, you know, and the snails do not move out of those high density areas. They can destroy spermatozoa. You know, whether that's what occurred here, I don't know, but there's certainly a lot of snails in this area. I'm pointing to Strophostyles helvola. This is called, the common name is beach pea, and it is a legume. And each leaf is made up of 3 leaflets, so that's a dead ringer for a pea, a plant in the pea family. And this particular pea, Strophostyles, can be found on the dune or in the swale environment. It has a great ability to grow through sand that buries it as a seed, but it's not too salt spray tolerant. But the interesting thing about this plant is that it has nitrogen fixing nodules, and we'll pull part of this up and see if we can see one. But who hasn't taken a picture of it?
I don't really know.
Yep. Okay. Yeah, this is the stolen nymph. Actually, fiddle leaf morning glory. Ipomoea stolen
Oh,
nymph.
okay. I thought
Yeah.
it was the goat foot.
Yeah, no, the goat foot has a bigger leaf. I could say you could think that, but it's not. This is the old marsh that's been exposed and eroded. So, it's all marsh. This is